Happy Friday! You should be on page 261 and 262. I'd like for you to start turning there. Make sure you have your ruler just in case, 2 sharpened pencils, and a highlighter. Okay, related to yesterday, we were talking about capacity is related to a liter, mass to a gram, and length to a meter. I just went ahead and went in the back of my book since it wasn't listed plainly. And out beside the meter, I wrote length. And out beside the gram, I wrote mass. And out beside of the, so you've got meter here, I wrote length. Gram, I wrote mass. And liter, I wrote capacity. And I just want to take you guys to these pages just to show you what it says right quick, okay? Okay, so I'm marking it with money because we're going to be using some money today. Okay, the meter is the basic unit of length in the metric system. So if you want to flip back to page 87 and circle length, I'll give you just a second. Okay, from that page, if you will turn to page 127, metric units of weight. The basic metric unit of weight is the gram. I also wrote mass at the top. Okay, mass, because they use that terminology. That is on page 127. Now, go to page 151. The basic metric unit of length of liquid capacity is the liter. The basic metric unit of liquid capacity is the liter. Okay, page 251. I want you to liquid capacity. I'm pretty sure we already highlighted that, but I just wanted you to remember those, okay? Now, we are back on page, sorry guys, taking me a second to get there. Okay, we are on page 261 and 262. I would like for you to go ahead and highlight 1 and write test 15, 2 and write test 15, 3, I'd like for you to highlight B as in boy, C as in cat, G as in goat. And on page 6, I would like for you to highlight A and B, okay? Again, sometimes I have you do homework, sometimes I don't. If today there's nothing highlighted under homework, but we're going to do some of it. And if a green is ever highlighted, then you'll know to do that as well. But I'll try to keep you informed each day. Okay, let's do the first one together and let's check. Okay, if you were not checking, you would stop here. Okay, the checking portion is this, if I did not make that clear yesterday. Okay, first thing you do is solve the side without the unknown. So this side does not have the unknown. 8 times 2 is 16. So then you bring back in your n plus 3 equals 16, okay? You have to do whatever you do to the left of this equal mark, do the same thing to the right of the equal mark. So in order to get rid of the positive 3, you have to do a minus 3. And you do that to the other side as well. So if you have $3, you loan me 3, you have none, you have just an n. 16 minus 3 is 13. So you have solved for n. But we want to check and make sure that it's correct. So we put the 13 back into the top equation. So it reads, 13 plus 3 equals 8 times 2. 13 plus 3 is 16, and 8 times 2 is 16. If you get down here and this is off, you got to go back up here and figure out what you did wrong, okay? Because this is your checking portion. I'd like for you to do B and C on your own, and I'd like to slide down, and let's do number 2, okay? 2A, can you cancel? Yes, you can. 2 will go into itself 1 time, and 2 will go into 8 4 times. 1 times 3 is 3, and 5 times 4 is 20. You cannot reduce that. Let's slide on down and do the next one. Okay, the first thing you do if you have got a whole number in a fraction is you put a 1 under it. Okay, now 7 times 2 is 14, plus 3 is 17. What number do you put that 17 over? The 7, the original denominator. Can you reduce any of that? Cancel any of that? No, you can't. So what do? You say 17 times 3 is 51, 51 over 7. That is an improper fraction. So you divide 7 into 51, 7 times 7 is 49. You have to borrow, make that an 11 and that a 4. You have a 2 left. 7 and 2 what, class? Sevenths. 7 and 2 sevenths is your final answer. Okay? Let's go on down and let's take a look, especially, I think you can fill in these blanks on your own, but B, C, and G are going to be on your test, and I want to make sure you write those down correctly. So, B, 1 kilogram is equal to how many grams, class? 1,000. Okay? 1 decimeter is equal to how many centimeters? Now let me check one thing. Hold on one second. I want to check something in the back of my book. Okay, I want you to remember, do you see decimeter right here? Decimeter? Do I have it? Yeah, right there it is. Do you see how that's a little m, a little d, and a little m? Okay, if it's deca, it's going to be D-A-M. Okay, so remember that. So D-M is decimeter. How many, 1 decimeter is equal to how many centimeters? 10, okay? 1 hectometer is equal to how many meters? 100, yes. Okay, I'm going to look back one more time at one thing just to see if it would be helpful to you. Okay. All right, now, so those are your answers. 1 kilogram is 1,000. 1 decimeter is 10 centimeters. And 1 hectometer is 100 meters. Okay? All right, so let's go on and take a look at solving this equation. I know these come back yesterday, and we had not done these in a while. So you ask yourself, this is in bushels, so you don't change it. But this has to be changed to bushels. So you put BU, you box it, put a line, and then you say, okay, if I'm going to go from pecks to bushels, peck to bushel, you go from smaller to larger. So you hold your arms in and you fly them out. So what does that mean you do, class? Divide. Okay, you remember that little thing we did in class? You divide. Okay, then you say, okay, how many pecks are in a bushel? How many pecks are in a bushel? And that is 4. Again, if you don't know that, you should be able to find it on what page? Let's see if pecks to bushels is on this page. And guess what? It is not on that particular page. But anyway, you guys have it in your book if you need to look back. Okay, you know that we did it on our pages. You can look this way for it if you need to. Or your mom could look it up on her phone if need be. But, so you have 4 pecks in a bushel. So that is your special number. Okay? Now, so you say, okay, what did we say we were doing? Dividing. So you're going to divide your special number into your given number. 4 divides into 24 6 times. 6 times 4 is 24, so that is 6. Okay? 6 minus 3 equals 3. Okay? So that's how you do it. Pretty simple. Okay? Now, over here, you're just going to write the missing terms. You guys can handle that. I'm not going to give you the answers for number 5. Number 6, I think you can handle that. Number 7 for homework. I'm going to do the first one with you, and I want everybody to do B and C. B and C. Okay? So you ask yourself, now look, the 3 is not larger than a 5, so we're going to forget about it when we use our 2. 2 will go into 4 2 times, but remember 23 goes into the whole 47. So what are we doing here, class? Dividing into the whole 47. So 2 goes into 4 2 times. 2 times 3 is 6, and 2 times 2 is 4. 7 minus 6 is 1, 4 minus 4 is 0. So you bring down the 8. 2 divides into 18. Now, I would probably have put, if you're not really thinking about that, and you say, okay, 2 will go into 18, you would put a 9 right there. So some of this estimating can get very confusing. Am I making sense? Like if you just didn't connect your brain and you said, okay, 2 goes into 18 9 times. But you got to remember that we are talking about a 23. No matter if we use estimation, we are still talking about 23. And 23 will not go into 18. So you have to put a 0. 0, 18 minus 0 is 18. So that is 20, remainder 18. To check, you write 23 times 20. Now, see how they did that? That always confuses everybody, okay? So let me tell you how I would do it if I were you. I would just say 23 times 20, okay? X that one out, put a 0, 6, 4, and then I would add my remainder for 478. That's what I would do because we have not been using this method of bumping that over, okay? Now when you bump that over, you just bring down the 0, then you say 6 and 4. Do you see what I'm saying? But we have not learned that way, and I think that may be more confusing than it does good. Now we're going to come down and we're going to take a look at a couple of these story problems, okay? I would like to do with you B, and I would like to do C, and I would like to do D, E. No. Let's see. Yeah, D and E, I think are the ones I was planning to do. Okay, so I'd like for you to do 8A on your own, and then B. Sergey's grandmother sent him $10 for his birthday, okay? He gave 1/10 of it to church. He spent 1/5 of it on a toy, and he spent 3/5 of it on a shirt. How much money does he have left? Okay. Now, we talked about being good stewards in our Bible lessons a couple weeks back. So this is the reason I wanted to point this out to you. His grandmother sent him $10 for his birthday. So he wanted to give 1/10 of it to the church. What did he give? His tithe. T-I-T-H-E. So that was $1 because if you divide 1 into $10, if you divide 10 into $10, you're going to get 1. So there you go, okay? Now, it says he spent 1/5 on a toy. So see, for this, you're going to divide 10, okay? So you divide the 10, see that? Into the $10, and that gave you 1. And here, you're going to divide 2 into the $10, right? I'm sorry, I twisted that in my brain. He spent 1/5 on the toy. So you see that 5, you divide the 5 into the 10, and that's the 2, okay? Here, the 10, you see the 10, you divided the 10 into the 10, that gave you the $1, okay? Now, it says, and he spent 3/5 of it on a shirt, okay? So how are we going to divide that? 3/5 of it on a shirt. Now, that one is confusing, isn't it? So, you say 10 over 1 times 3/5, okay? So you can cancel. And then 2 times 3 gives you 6 over 1, so that equals $6. Do you see how you can do that, class? Okay, makes sense? So you got the 3/5, you got the $10, you put the 1 under there, you multiply it out, you cancel, okay? So $6 for a shirt, okay? And then it says he spent how much money? How much money did he have left? So if he spent $1 plus 2 plus 6, 1, 2, 3, 3 plus 6 is 9. So then you just say $10. How much did he have originally? $10. 10 minus 1 gave him 9. 10 minus 9 gave him 1. I apologize. My phone keeps going off and I'm afraid it's going to cut me off. So 10 minus 9 equals $1. So $10 minus the 9, which were those added together, gave you $1 left. And that's what you were supposed to figure up. Okay? Now, So I can see how you look at those sometimes, guys, and that can be very overwhelming because that is a lot to figure out. But guess what? You have been given all the skills to do that. Okay, if this video cuts off, don't worry about it. We will just let it end where it stops. But I'm going to try to finish the last ones. Change a dollar bill into 14 coins. Okay, you can do that any way you want to. Many combinations are possible. But I'm going to give you the combination that they came up with, okay? You've got 5 pennies, 2 nickels, 6 dimes, and 1 quarter. Okay, let's count that. 25, 35, 45, 55, 65, 75, 85, 95, 96, 97, 98, 99, $1. Now my favorite way to do a dollar is 4 quarters, right? But it said, how many did you need to use? 14 coins. So that was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay? But there still may be other ways. Okay? Now, Jill spent $2.55 on notebook paper. She gave the clerk $3. What 3 coins did she receive as change? Okay? Let's go back. She gave the clerk how much money, class? $3. 1, 2, 3. Okay? It says that she spent $2.55 on notebook paper. So this is how much she spent. So she gave the clerk she gave the clerk $3. She spent $2.55. We have got to count up like we're the clerk. But we are using only 3 coins. Okay? So let's think about that a minute. Y'all might have to help me. Okay, typically it wants us to use the smallest increments. So up until today, it would have said to use the smallest increment. So I probably would have done something like, I probably would have done 5 cents to get me to 60, and then maybe 75, and then $1. Maybe something like that, okay? But there's several ways to do it, okay? The way we should do it to use only how many? 3 coins is we're going to do 65, 75, $3. Okay? This is the $2.55 that was spent. We're going to $3. That goes to 65, to 75, $3. And we only used how many coins? 1, 2, 3. Okay? Now, we have one more for you, the very last one. David spent $1.17 on a squeaky toy for his new baby sister. He gave the clerk a $5 bill. Okay? The clerk gave him 3 pennies, 1 nickel, 2 quarters, $3 bills. Did he receive the correct change? Okay, I'm going to let you help me with that. David had $5. He paid the clerk for a new squeaky toy for his new baby sister. That was $1.17. Okay? He should get back, okay, $1.17, 18, 19, 20, 25, 50, 75, $1. That makes it $2, right? 2, 3, 4, 5. Okay, so I'm going to move all this other money. Okay, so he should get back $3, 3 quarters, a nickel, and 3 pennies. Okay, it said that the clerk gave him back 3 pennies. Okay, that's right. 1 nickel. That's right. Up 2 quarters, but how many was she supposed to give back? 3. And $3 bills. So she shortchanged him the 1 quarter, didn't she? Okay, so the answer to E is no. Okay, I encourage you to do like Miss Nance does and get out your money and some change, and whenever you're doing these problems, actually work them out and think them through. That's the best way to do it. I hope you guys have learned a bunch in math today, and guess what? We are getting close to summer. I hope you have a fantastic weekend. Bye-bye.